Okay, my algebra students, last chapter study guide for a test. Here we go. Here's chapter 8, study guide solutions. All right, as we know, we have been looking for making solutions when it equals 0, right? So our main equation has been our quadratic equation, which is ax squared plus bx plus c. And obviously that's y equals all of this, but we are solving for the x-intercept. So in order to solve for an x-intercept, y has to be 0. So we're setting everything to solve for the x-intercept when y equals 0. So at number 1, it says, what are the solutions to this already factored polynomial when it equals 0? Well, we would just set these equations to equal 0 and solve for our x values, which are going to be 3 over 2, or 1.5, and negative 7. That would be our x-intercepts. Now, on number 2, we have to factor first. Number 1, it was factored for us. But number 2, we have to do the factoring. And we can see this is a very simple x box, 2 numbers that multiply to be 27 and add to be 12, which are obviously going to be 9 and 3. So these are our factors, but they're set to equal 0 to solve when what the actual x-intercepts are. And that's going to be negative 9 and negative 3. On number 3, in order to factor this, we have to first put it into standard form. Just a little hint, if you didn't get why, we had to subtract those over there. First, I put it in standard form, and then I can factor, right? We want to put it in that standard form, and I'm going to go ahead and X box what are 2 numbers that multiply to be a positive 10, but add to be a negative 7. So that's going to be negative 5 and negative 2. And these are our factors. And when we set them to be 0, we can solve for the x-intercepts, which are 2 and 5. On 4 and 5, we are solving using square roots, right? We know we use square roots because there's no bx value, right? There's no bx value. That means I cannot x box them, and they are either a difference of 2 squares or maybe a perfect trinomial. And in the first one, because there's no bx value, I can see that I'm going to solve for a squared to root it. So I have to isolate my exponent. So I first add 12 to both sides and divide by 4, and then I get a squared equals 16. I square root both sides, and I get that it could be plus or minus 4, right? Because remember, it's 4 times 4, or negative 4 times negative 4. So our answers for square roots are always a plus and a positive and a negative version. Okay, on number 5, we have a difference of a perfect trinomial that has been factored for us here of x plus 7 squared, which if I multiply that out, I would get x squared plus 14x plus 49. But it's already factored for us as a perfect trinomial. So I square root both sides, and I get x plus 7 equals plus or minus the square root of 12. Now, the square root of 12 is not even, so I look inside of there and think, what are the perfect squares in there? And I see it's 4 and 3, and I can square root 4, which is 2, and I can't square root 3, so I just leave it in there. We call this a simplified radical. I go ahead and isolate x by subtracting 7 from both sides, so I get negative 7 plus or minus 2 square root 3 as my final answer. All right, let's take a look at number 6. It says, what should be added to both sides to complete the square? Because on number 5, we looked at a perfect trinomial. So if I wanted to make a perfect trinomial out of x squared plus 8x, what would I do? Well, I would cut 8 in half, and I would square root it and add it to both sides. So I'm going to be adding 16 to both sides in order to make a perfect trinomial, and then I can solve by rooting, because there is a bx value, so I can't just square root. All right, on number 7, I'm going to solve by completing the square. First, I have to make room to complete the square, so I need to move the 32 to both sides. Then I cut 6 in half, and I square that. 12 in half, I get 6, and 6 squared is 32, and I add that to both sides because it's an equation. What I do to one side, I must do to the other. So my perfect trinomial that I just created is c plus 6 squared, and that equals 4. I square root both sides to solve, and I get c plus 6 equals plus or minus 2, and then I have to subtract 6 from positive 2 and subtract 6 from negative 2, giving me my final answers of -4 and -8. On number 8, it's a little tricky. I first have to make room again to complete my square. And, oh, my bad. Hold on. Okay, sorry about that. I solved it by completing the square, and I actually need to solve it using the quadratic equation. So a quadratic formula says that -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Our first thing is we need to identify a, b, and c, which is 1 for a, 3 for b, and c is -28. So we plug into our equation, getting x equals -3 plus or minus 9 minus 4 times 1 times -28. So then we have -4 times -28, which is 112, plus 9 is 121. So then we have -3 plus or minus the square root of 121 all over 2. And the square root of 122 is 11, so we end up with -3 plus 11 divided by 2 and -3 minus 11 divided by 2, giving us 8 over 2, which is 4, and -14 over 2, which is -7. So our answers are 4 and -7. All right, now on 9 and 10, we get to choose whatever method we want. On 9, because I see there is no bx value, I know I want to solve using roots. So I isolate my x squared, and then I solve by square rooting, and I get plus or minus 4. I could also have divided off the 3 and then seen that it was a difference of 2 squares, giving me x plus 4 and x minus 4, and solving and still getting positive and -4. On number 10, I automatically say I'm going to take a GCF off. Got to get rid of that GCF every time, make my life easier. And then I'm just going to easily Xbox it instead of having to AC method. So I have two numbers that multiply to be -4 but add to be 3, which would be 4 and -1. Then my factors are going to be x plus 4 equals 0 and x minus 1 equals 0. I subtract 4 and I add 1, so I'm going to get -4 and +1. All right, on number 11, we see this kind of scary equation. It says the height of this ball is being, it is modeled by getting hit into the air and then landing. Notice that there is no c value, which means the original height was 0, right? If I go ahead and draw this, this is what this looks like. And where x is the time in seconds. So I know the x value represents time and the y values represent the height. And it says, how long was it in the air? So I need to solve for my x-intercepts. I know the first x-intercept is going to be 0 because it says that the b value is 0, but I can factor that and see it. I'm going to go ahead and just factor it using greatest common factor. And then I solve. -18x when it equals 0 is just 0. And I knew that because that was my starting point. And then I have x minus 3 equals 0. And I add 3 to both sides. And so I know my other x value is 3. So this ball was in the air for 3 seconds before it landed, or when it landed. So on number 12, it says, what are the zeros, or what are the x-intercepts here? And we know it's 2 and 5. Or we could say that it was 2, 0 and 5, 0, to be more specific. On 13, it says to tell whether this graph opens up or down. And because the a value, it's all about the a value on these kinds of problems. And the A value is positive. And because I know that, it makes a happy face. It is positive. On number 14, it's a negative graph, which makes a sad face. And because of that, it has a maximum amount of positive Y values, right? It will not have all the positives. If it were a positive graph, then it would have all the positives, depending on where it started, but yeah. On number 15, it asks us to go ahead and find this parabola, the vertex here, which I know is 2 and negative 4. And is this a minimum or a maximum? And because it's positive, it has a minimum amount of negativity. And that Y value always determines it. And the Y starts at a minimum of 2 and it's greater than that, right? It's not a maximum because it can go above 2. 16, what is the vertex of the graph? And I know that the vertex stands for a very specific X and Y value, where X represents the axis of symmetry and Y is the Y value. I solve for the X first using our formula of negative B over 2A. And I go ahead and plug in my numbers of negative B, which is, it's a negative 10 over 2 times A, which is 5. That's going to be negative 10 over positive 10. Sorry, negative 10 over positive 10, which is a 10 over 10, which is 1. So my axis of symmetry is 1. Well, how do I solve for the Y value? Well, it tells me the equation right here. Y equals 5 times the X squared minus 10 times X plus 3. So I just plug in that X value to solve. So it's 5 times 1 squared minus 10 times 1 plus 3, which gives us 5 minus 10 plus 3, which is negative 2. So my vertex is 1, negative 2. 17 asks us to graph. 17 and 18 asks us to graph, and it asks us to use a table. And we think about it, why would we want to use a table on these? Because there's no bx value. Because there's no bx value, I know that the vertex x value starts at 0. And because it starts at 0, then the y-intercept is the y value. So it's going to start at 0, 3. On this one, I want to do numbers that are bigger and smaller, right? So one is bigger than 0. I plug that in. So I get negative 1 times 1 squared plus 3 is going to be negative 1 plus 3, which is 2. And I reflect that on the other side. And then I do my 2 value. And negative 1 times 2 squared is going to be negative 4 plus 3 is negative 1, right? Oops. Is negative 1. So I'm going to clarify that this should be negative 1. Okay. And then we go ahead and graph our points. Yeah, let me just fix that a little bit. It's a little messy. Graph our points. And there you have it. Okay. On 18, again, we don't have a bx value. So our vertex x value will be 0. When we plug that in, we get the y-intercept of negative 5. A point bigger would be 1. And 2 times 1 squared minus 5 is going to be 2 minus 5, which is negative 3. And I reflect that. And then 2 squared is 4 times 2 is 8 minus 5 is 3. And I go ahead and graph those points. All right, our last 2 questions are going to be graphing from scratch, right? So first we have to find the vertex because we have a b value. So we use our negative b over 2a to solve for the x value, which is going to be 2. And then we plug that in to solve for our y value, which is going to be 7. Now, a point that is bigger and smaller, which I'm going to go ahead and do the smaller first on this one. I get 1 and 0 because I want 0 because it reflects, right? And then I can go ahead and plug in 1, negative 1 squared times negative 1. It's just negative 1. plus 4 plus 3 gives us 6. And I go ahead and graph all those points, and I draw. And I'm going to move on to the next one. I get negative b over 2a. So my vertex is going to be negative 1 and negative 5. I do points bigger and smaller. And I go ahead and graph those points as well. Now the last thing it asks me to do is to label my vertex. So I'm going to label my vertex, which is 2, 7 on the first one, and my axis of symmetry, which is x equals 2. And the number 20, my vertex is negative 1, negative 5, and my axis of symmetry is negative 1. Alrighty, we'll be going over this in class before we take the test, or maybe we'll do a practice test. It will all decide on how you guys are feeling. All right, talk to you later. Bye.